up until now, finding the slope on a straight line is easy because the slope of a straight line stays constant. You remember how we talked about slope, and you know that the regular equation for a straight line is y equals mx plus b. M is the slope, and if you don't remember slope, go back and look at that previous video. We talked about how to figure that out. So y equals mx plus b, well, that's it. Now what happens if you're trying to find the slope of a line that contacts a curve? Because the slope is always changing. If we take a look at this standard curve here, y equals x squared, we know that if we have a given point, like for example here, along the curve, the slope will touch at only one point on that curve, so that we would end up with something that looks like this. As long as that line is only touching the curve at one point, we can say that at that particular spot, the slope is such and such, but we don't have y equals mx plus b, so how are we going to do it? Well, this is what's called the first derivative of calculus. We can approximate the slope of that red line by taking, say, another point that's nearby, like, say, over here, and what we could do is we could say that now what we've done is we've got our original point x here, and we moved it over a little bit. Let's say that we added a value called h to it. So let's say this distance here is h. This point here now becomes x plus h. And we know that if we took, say, another sloped line here at x plus h, it's going to be kind of close to that line there. And as we shrink h and get closer and closer to x, that the slope of that second red line will start to approximate the slope of the first red line. So maybe it's a little bit steeper as we get closer and closer back to x. As h goes down to 0, we get the original line there. How is this going to help us? Watch and learn. So when we have our second point here, which is x plus a little distance h, our function y now becomes our new h, which is x plus h, squared. So this point here, y equals x squared. So far here we have y equals, whatever that is, x squared. Here we have a new value of x, which is the old x plus h. And this is now x plus h. And we square all of that. Think about that for a few seconds. It'll come to you. Now we go back to our original proposition where slope is the difference in y values, which is to say this distance here. Remember rise or run, folks? So our change in our y values over our change in our x values, which of course by definition is that little value h. So we can figure that the slope here, joining those two lines, or those two dots rather, for this x and this x here, is almost the same as the slope on that point as h disappears. So what we would end up with here is that the slope can be approximated by saying y2, which is x plus h squared, minus our original y, which of course is x squared, divided by our run, which of course is our second x value, x plus h, minus x. At this point, a lot of times people would say that the slope now, basically as h goes to 0, h disappears, so this point moves closer and closer back to this point, and that means that the slope between those two dots gets closer and closer to what we really want to figure out, which is the slope at that one dot there. Well, we could say at that point that if this x becomes this x, that everything cancels out, we end up with 0 over 0. Not very useful. The key to figuring out the first derivative is to rearrange this so that we don't end up just plugging in our values and everything cancels and we get 0 over 0. So for example, if we expand this out and write it a different way, we get x squared plus 2hx plus h squared minus x squared. There's our original x squared. That hasn't changed. On the bottom we just have x plus h minus x. So the x's, we'll cancel those out for a second there and take this. Now on the top, the x squared is also canceled out, but now we're left with something just a little bit different here. We have 2hx plus h squared over h. We cancel out the h's, we end up now with 2x plus h. And as we shrink down that value of h here, so in other words, the two dots move closer and closer and closer, which means that our approximated slope starts to match exactly what we wanted, which is the first red line. Then, as h goes to 0, that cancels out, we're now left with 2x. So the slope of that original tangent here, which is the first red line, I'll put the arrows on it to differentiate from our approximate, is now 2x. This is called the first derivative of calculus, and it is written in the following way. If we have our original equation, which is, let us call it y, the change in y, remember how we talked about that triangle, which means change, delta. Delta started with d, so we call that the change in y with respect to a small change in x, dy by dx, which means for every small change in y versus a small change in x, we have, of course, rise over run, and we end up with dy by dx in this case equals 2x. This will work for any point, any value of x, including negative numbers. Try it. And remember, these videos, I do this to make your life easier because I love you guys.